When working with equations with variables on both sides, we can normally stick to a pretty solid pattern. Normally it's easiest to take this variable on the right, add it or subtract it over, so 3x we would minus over, and then do our two-step equation steps. We'd minus the 8, end up dividing, follow that same pattern every time. Sometimes we start with some unique setups though. What if we don't have numbers on both sides? When we have a setup like this, we kind of are forced to do one step first. We don't want to minus this 3x over because then we're left with 0 on the right side. We'd have nothing over here. So in this situation, we would want to take the negative x and move it to the right. So it's going to go against our normal pattern. But this way, we still have a number on the left and we still have a term on the right with our variable. Then we could do the opposite. Opposite of multiplication is division. So 8 divided by 4 gives us 2. And the 4 divided by 4 cancels. It gives us 1, but we don't need to write a 1 in front of the variable x. So always just keep in mind that if we're missing some of the stuff we normally have, we want to get all the variables on one side, all the numbers on the other. If it had been written this way with the 3x on the left and the negative x plus 8 on the right, we would have wanted to add the negative x still, but this time we're moving it to the left side. So we have to be a little bit flexible when these unique situations come up to make sure we know which direction we need to move our variable over. The last unique situation, and this didn't ever happen with one or two-step equations, but now where we have variables on both sides, we can get kind of an odd thing happening. If I do my normal setup, so we have variables on both sides, normal numbers on both sides, easiest to take this right variable, it's currently positive, so we would have to minus it from both sides. We know 5x minus 5x cancels, leaving the 12 behind. And over here, 5x minus 5x can also cancel. 5x minus 5x is 0, but we don't need to write 0 in. 0 minus 5 is still negative 5. So this is a very odd thing to happen. It only happens very rarely, where the variables disappeared completely. There are no variables left. And this can only happen when you have variables on both sides to start with. So this never happened with two-step or one-step equations. So when that happens, we have two situations. The first is what you're seeing here. Negative 5 equal to 12 is just not true. Negative 5 never equals 12. Doesn't make any sense at all. So this means we have no solution. It just didn't work. You can't do it. Let's change this one more time. And instead of starting with negative 5, let's start with positive 12 here. So now when we do our steps, we still take that negative 5x and subtract it from both sides. What we're left with is 12 equals 12. Even though the variables canceled, we still have no variables. This time we're left with what we call a true statement. 12 does equal 12. That makes sense. This means whatever number we use, it would work. So this is called all real numbers as our solution. We could plug in any number and it would solve this problem. So if we said, well, let's make x 1, I have to replace x both times with 1. And when we solve this, we have exactly the same thing. We'd get 17 both times. And we could keep doing this. We could say, well, I'm going to replace it with 2. I'd get the same answer both times. We'd get 22 on both sides. So any number that we want to choose for x, it will work. Most of the time with our equations, we're getting down to just one number. There is literally only one number we can find that will solve this equation. On this situation, any number we want to use would actually solve the equation. So those are all our different unique situations that can come up, so our special cases we might have to work with.